Hello, I'm Ed Overstreet, and welcome to the Night Sky Imaging YouTube channel. Uh, we're going through PixInsight and the workflow that I use, and let's get started and move over to PixInsight and pick up where we left off. Okay, and I think that'll do it. Okay. When we last were together, we used the dynamic crop feature, and in doing so, we were able to crop all three of our mono images, the HA, the S2, and the O3, so that they were exactly the same crop. Now we're going to use another dynamic process called the dynamic background extraction, and this is an invaluable tool in PixInsight. It will help, if not completely eliminate, the gradients that you have in your image. As you can see, we've got kind of a reddish hue here, and then it becomes kind of green. It goes back to purple reddish influences, back to our nebula, and then to purple. But there are gradients running across the image. Some of it is the gas, the green, and some of it is just the gradients that are inherent in light polluted skies, which I clearly have. So what I'm going to do is I'm going to run the dynamic background extraction tool, and you can find that in Process, All Processes, and then you come down to the dynamic background extraction. Now, just a word of warning: if you happen to have the dynamic crop window still open and you try to open the dynamic background extraction, it will not open. You can only have one of the dynamic processes open at a time. So I have a saved process for dynamic background extraction. I call it Edges, and I'm going to bring it up, and what it does is it puts the reference boxes for the background all around the edges of my image. And what I do is I borrowed this, or got this idea from Sean Nielsen, and I'm going to open this up for you to see how these settings are set. Tolerance is 2, shadow relaxation is 6, smoothing factor is 0.250, unweighted is unchecked, then sample fraction is 0.050, continuity order is 2, and the sample radius is as large as I can make it, and I'm going to resize all, and that even increases the size of the boxes from when it was last used. I used 10 samples per row across the top and bottom and sides, and the weighting factor minimum is set at 0.750. Under model image, it's on auto by default and downsample by 2 by default, and 32-bit 754 floating point by default. I leave that alone. I'll run this at least twice. I'll run this in division, and then I'll change this to subtraction, and I'll run it in subtraction. I have unchecked normalize, and I have checked discard background model. I don't need it. Although if you want to see what the background model looks like and how the gradient is removed, check it. And replace target image. So those are the settings. And what I'm going to do is the only difference that I make is I'm going to go ahead and move these into the corners, and I'll move them away from a bright star, but I'm not that concerned about stars being in the image. I won't deliberately put one in the path of a bright star, but the background occupies much more geography than the star does, and it's the background that's going to use to clean up my gradient. And the theory is that the gradient is going to reveal itself at the extremes, and now I'm going to delete this one, and I'm going to delete this one because it's in the middle of my nebula. Other than that, this is the only modification or modifications that I'm going to make. And as you can see, I'm moving these larger boxes to the edge and deliberately away from any large stars. I may end up putting an extra one in the corners. But that's it. Now, I'm going to minimize these and take this process and drag it to my desktop, because I'm going to use this a couple of times. So let's apply the gradient removal by clicking execute. This is just a spectacular tool, and Sean's scheme is brilliant. I'm going to move this to where I can get back to it. Okay, let's stretch the image. And we're going to close this, and then we're going to open it again by clicking on the process, and it's going to bring back the same set of boxes because that was the process I saved. And now I'm going to go down to target image, and I'm going to change this to division, and I'm going to execute. As you can see, I have a slow Mac. And I'm going to close this now, and I'm going to restretch it. Now on many occasions I will come back, and or I'll just open this back up and do it again and again until I feel like I have completely eliminated the issues of gradients. So because I'm going to save this process, I'm going to save this project, I'm going to keep this process because I may come back and do this again, and I'm going to change the name to DBE _ NGC 7822, and I'm going to move this over by the process that I call dynamic background edges. So now I have this saved. If I want to come back, it's going to recreate these boxes precisely where they were when I ran the gradient for the first time, gradient removal for the first time. Okay, folks, that will bring dynamic background extraction tool process to a halt. I'm going to go up to File, Save Project, and it's already been named the NGC 7822. I'm going to, before I do that, I'm going to change the name of this to DB Dynamic Crop and DBE Dynamic Background Extraction, and I'm going to drag that to the side. And so far move these down here. So far, what we've done with this image is we've converted it to an SHO image using the RISTA equation in PixInsight, and we've ran the dynamic crop and the DBE. Now, prior to that, we did a linear fit, and we linked the channels in all three, HA03 and S2. So now we're ready to save this project. And we'll have to write over it, and we'll say yes. So folks, that will bring this one to an end, and you'll see me back here later when we ran the multilinear transform, which is a transformation, which is a noise reduction process that I like to use in the linear state before we do a color correction and color calibration, and before we stretch the image, which is coming up.